The chance to shape your future is here. Learn and connect with exciting new opportunities. Are you ready for the next step?
Good morning, everyone, and welcome to this live session. I'm going to pass over to Hannah, who's going to lead the session with you this morning.
Hello, everyone. I'm Hannah Fulliger. I'm the events coordinator at CSA Catapult. Welcome to our session at the Centre of Net Zero for Emerging TechFest 2021, presented today by Amar Abid Ali, Chief Commercial Officer, and Dr. Andy Sellers, Strategic Development Director at CSA Catapult. A few notes of housekeeping before we start. Please submit any questions for Andy and Amar via the chat. At any point, we welcome them throughout the session. A PDF of today's slides is available in our exhibitor portal. And do let us know your thoughts on the session today. We'd love to continue this conversation with you, so please email us at collaboration@csa.catapult.org.uk. I'll now hand over to Amar. Thank you, Amar.
Thank you, Hannah, and good morning, everyone. So we're excited to have the next hour with you to discuss exactly how compound semiconductor application Catapult is at the center of net zero. We have quite a packed agenda, so let's get started. Hannah, maybe the next slide, please. Appreciate it. So what I'll walk you through over the next half an hour or so is a little bit of the history of the net zero timelines and how we got here in the first place. I'll talk about the challenges, mainly the energy challenges that we're facing today, and it is quite a complex landscape out there. Then I look at the pestle analysis across the board. So we look at the political, we look at the environmental, societal, technical, economical, and legal challenges that are facing us and how we can tackle those. And then I look into the targets and where we need to be at in order to become really compliant with this net zero initiative that's out there. I'm then going to look at the UK focus on this. So where does the UK stand in all of this? And what do we need to achieve in order to achieve a net zero by 2050? And then finally, I will end up my session with how compound semiconductors themselves are useful in the areas that we're going to be focusing on here. And then I'll hand over to Dr. Andy Sellers for additional information in terms of what we're doing, working with various organizations, and what the CSA Catapult is all about as well. So with that, the starting point here for us is just a brief history of time, if you like. In 2008, there was a Climate Change Act that was signed, followed by a Paris Agreement about 8 years later, so in 2016. And then the UK Clean Growth Strategy was pretty much there in 2017. And then in 2019, the net zero by 2050 was kind of signed with the decarbonizing and decentralizing of the energy initiatives in the UK. And in 2020, we were supposed to have the COP26, which obviously was cancelled due to COVID. And it's postponed to November of this year, so 2021, 1st to 12th of November in Glasgow. To meet net zero carbon emissions, there are a lot of initiatives out there. But before we get into those, let's really get into the challenges that are facing us from an energy perspective. And the reason why we look at the energy generally, because it actually touches quite a lot of the areas there. Next slide, please, Hannah. So looking at the energy challenges that are facing us today, and this is a global picture, by the way, not just necessarily UK-wide. The first thing is we need to look at all aspects of energy. So whether it's the generating the energy, whether it's the distribution of the energy, or whether it is the delivery of it. And the pace of innovation needs to catch up. The pace of innovation in the last perhaps 50, 70 years have been quite stagnant in comparison to what we need to do in order to actually achieve the targets that we need to achieve by 2050. Certainly, there is a much more increased demand at the moment. And by 2040, the energy consumption is estimated to increase by almost 50%. So it's a significant amount of increase, which means that we need to deal with the increase in demand of the energy, generation, distribution, and the rest of it. Of course, the additional element here is that we also have to transform the way that we are using energy. You are seeing a huge shift at the moment from moving from crude oil and gas to renewable energies like solar, wind, and so on. Of course, the carbon neutrality becomes much more interesting just through what you've seen in the last slide, which is, the net zero initiatives that are out there. So a critical issue becomes, how do we reduce CO2 emissions from all the energy sources that are out there? And then in order to do that, of course, we need to replace it with renewable energy. And that is, at the moment, only 20% of the world's primary energy supply. And that's, it needs to go much higher level than that. And I'll talk about those in the next few slides as well. Hannah, next slide, please. By the way, if you guys have any questions, feel free to put them in chat, and we'll deal with the questions at the end of the sessions.
Amar, just to clarify, the questions go into the hub itself, and I will paste them into chat.
Perfect. Apologies. Yes, absolutely. So let's talk about the pestle analysis then on this. Next slide, please, Hannah. Okay, so main things to actually focus on here on the political side of things is that we have this in law now that we need to be zero emission by 2050, right? So we know that the government has also said that no new petrol cars or diesel cars need to be there by 2035. In fact, UK is a leading country in the world for this particular thing. And of course, there is a lot of investment at the moment from a political perspective, and that investment is really going in part into making it a greener economy in general. So a lot of the grants that have been done in the past have really been in the center of this net zero initiatives from a political perspective. The Faraday Battery Challenge, quite a big project, 246 million. We had the Charging Infrastructure Investment Fund, about 400 million. We had the plug-in car grant schemes from the government, which was £3,000 for an electric car or 8,000 for a zero emissions business van. There is the home charge scheme, which is £300 for installing EV charger at home, and so on and so forth. There is a lot of these political initiatives that are coming on board, and we believe there are going to be more to come. This is just the start of the journey here. Next slide, please, Hannah. So from an environmental point of view, just wanted to kind of break this down into a couple of areas here. So the first circle you see on the left-hand side kind of tells you the total UK emissions overall. And what's clear there is transport and energy supply kind of make up a half of the total UK emissions that are there. If we take transportation alone, which is the 27% that you see, you will find the second circle, which is in the middle there. And you can see that road transport accounts for 91% of the total transportation. Now, if we look at road transportation emissions in particular and break that down, we see that passenger cars make up 61% of that. So where do I want to go with this? Essentially, passenger cars play quite a big role within net zero. And you'll see why that's relevant to us as well when we move forward as to what compound semiconductors can do to actually reduce that. So the areas that we will focus on from a compound semiconductor application catapult perspective is transportation and energy supply, and they make up, as you can see here, about 50% of the total UK emissions that are there. Next slide, please. So from a social point of view, looking at the pestle analysis here, the main societal changes that are required in order for us to actually be transformative towards the net zero is really to be much more aware of the carbon footprint. And generally that tends to happen gradually with the societal changes that are required. So number one, for example, car sharing initiatives, reduced travel. We've seen that over the last year's period with COVID, a lot more meetings through Zoom, of course. And so whether that trend is going to continue, that would be very helpful as well for the way that we emit gases, CO2 gases. And if you look at the new technologies that are out there, transportation as a service is really an up-and-coming trend at the moment. And that could mean that instead of owning a car, we actually just subscribe to having a transport available to us. And a lot of the areas of autonomous driving at the moment is coming to the fore, and you see many more companies focusing on this. So in terms of the benefits we get, of course, more cost-effective transportation. You'll see there's a cost of about £4 per 100 miles or so, which we'll talk about in the next slides. But of course, there are health benefits there with improved air quality and ideally lower hospital admissions due to respiratory diseases and the like. And of course, this should, hopefully, this new push towards net zero should tremendously increase the employment opportunities in the new greener industries and reskilling for those industries. Next slide, please. So the technological challenges, if you like, really, when we look at them, we are looking at them from the perspective of that half of that pie, the 50% of the pie. We can't, from a compound semiconductor application catapult perspective, we can only look at the areas where we can have quite a lot of impact. Now, of course, there are other areas, for example, the agricultural industry can do quite a lot more. But the focus of today's presentation is really from the technologies that we can really impact on. So what the compound semiconductors, what they can do generally across the board is, because they are part of where the electrification of vehicles are, for example, in the converters, inverters, chargers of the electric vehicles, they tend to bring out many more benefits to this. For example, improved efficiency. Reducing the losses that you have is a huge advantage, because that gives you a much better battery efficiency and therefore a better range. And so by also reducing the heat, the thermal management within the car as well, you are essentially removing quite a lot of additional components there, and by definition could have systems that are more affordable. And that translates generally to potentially smaller batteries or more efficient batteries and longer range, and you can actually have any of the above and be selective about how you want to deliver those benefits. I'll talk more about the technological areas for compound semiconductors and how we actually deliver those efficiencies in the next few slides. Next slide, please, Hannah. So from an economical point of view, just wanted to highlight a couple of things here, running cost comparisons. So if you look at, and this is an individual economical benefit, if you like, rather than a societal one generally, if you look at using a petrol diesel car at the moment, the cost is roughly about 13 to 16, 17 pounds maybe per 100 miles. Compare that with an electric car, we're talking about 4 to 6 pounds per 100 miles. And of course, if you have renewable energy installed, solar or wind or whatever, then that cost is pretty much negligible as we move forward. So the cost is going to reduce dramatically as we move forward with renewables coming into place. Of course, the cars require lithium-ion batteries, and the cost of those particularly have fallen dramatically, which means the cost of electric cars generally will reduce overall in the coming years. So it's a big market. It's the opportunity is absolutely tremendous here. What we look at in the graph to the left-hand side, you can see between 2008 to 2018, we're talking about 2%, 2 to 2.5% of new electric cars as a percentage of the total car registrations. So it's negligible, really. And in order to actually be, in order to achieve the target of 2050, we need that number to increase dramatically to about 75%, 80% of all cars to be electric vehicles. So there is a tremendous opportunity here with the electric vehicles, and you can see the trends coming out, and you can see the way that the industry is benefiting from a renaissance, if you like, of new electrification over there. Next slide, please, Hannah. So from a legal perspective, there's a couple of things to highlight here. One is obviously there is an end of sale for all new diesel and petrol cars by 2035. As I mentioned earlier, there is the automated and electric vehicle bill that is coming through. And also there are lots of changes in the building regulations from an energy efficiency perspective as well that have happened and are ongoing on this. So the legal aspect of this, when it goes to Parliament and the bill gets signed, it basically helps industry to focusing on areas that they can help with the efficiency of everything we use day to day from an energy perspective. So just a quick recap, what we went through so far was the history. We went through the main challenges that we see in the energy domain overall. We then looked at the pestle analysis, a general view. By no means is this a comprehensive one, but just wanted to highlight a few things that are currently out there for everybody to see. Let's talk about the targets. Next slide, please, Hannah. So in order to get to 2050, I just want to share with you a few numbers here in terms of where we are. So we did talk about the energy generation, and then of course we need to distribute this and deliver the energy. So generation, distribution, and delivery really are three major areas where we need to dramatically increase the output and make it much more efficient. So the target, for example, for solar is about 52 gigawatts and 86 gigawatts for wind. We're talking about 5x potentially of the existing setup, at least in best case scenarios here. In terms of storage, huge amount of energy storages are going to be required, up to 28 gigabyte storage in order to meet the target. Of course, a lot more interconnection between UK and Europe, about 20 gigawatts between the UK and Europe. And then, of course, even in the marine, there is an expectation that there is about 13 gigawatts by 2050. So we're talking about big numbers here, and they can only be achieved with higher efficiency of what we currently use, better dispatch of this, smaller footprint and more aggregated supply chain. And of course, there's going to be a lot of land requirements for this, especially if we're talking about solar or in the case of offshore wind. Of course, it needs to have a lot of the installation happening in the next few years for us to actually reach that target by 2050. So let's look at the UK situation then in all of this. Next slide, please, Hannah. So this is a summary of what you've seen before. If you look at the percentage of greenhouse emissions there, the clear element here that I wanted to highlight is that between transportation and energy supply, you've got roughly 50% of the total energy emissions, of course. But that actually gets itself into the business element and potentially even the agricultural side of things and residential and others. So having an efficient energy supply can actually permeate throughout the supply chain there as well. Next slide, please, Hannah. Next one. We've walked through this one, so I'm not going to talk about this one in particular. This is just another slide showing exactly the same thing. Right. So in terms of the UK net zero target, then briefly, the emissions produced versus the emissions removed, it's what net zero is about. So it's not about having no emissions whatsoever. It's about achieving a net zero CO2 emission. And in order to achieve that net zero, there needs to be technologies in producing low emission in the first place, and technologies that remove emissions out of the atmosphere. And so you will see a trend that's moving in both directions, right? How do you create technologies that take out, if you like, the emissions that are out there? And how do you make technologies that don't emit in the first place or emit very little? And so in the foreseeable future, in the next 30 years or so, we're looking at seeing a potential huge upside on having the low emission production. And then of course, we will have an upside in technology that will remove the emissions from the atmosphere. So transportation, for example, is expected to be at zero emissions by 2050. You can see the electricity generation as well. A huge reduction in heating from 2,700 to 138 kilograms of CO2. So huge decrease in both transportation and heating and electricity there. But you can see, for example, in agriculture, it's not possible to reduce that fully to zero. So again, technologies to remove emissions would be very much very required in the future. Next slide, please. So looking at the main areas then that we focus on in the compound semiconductors overall, and Andy will talk through how we do this in general with our existing setup. So energy supply definitely is the main area of focus for us, specifically in the renewable energy side of things. And that's because we can reduce losses by about 90% using compound semiconductors. And there you can see compound semiconductors in solar power systems and inverters in those systems. Of course, inverters in the wind energy and smaller microinverters, if you like. And in terms of industrial operations, there is a lot of renewable energy requirement there as well, thermoelectric power generations as well, and solar energy for commercial applications is a totally different requirement than it is for standard domestic. On the domestic side of things, again, the solar panel comes into it, the solar heating systems as well. And the big one for us really that we've been working on in multiple projects is transport overall. Zero emissions using electric vehicles overall, the charging infrastructure required for that, and the propulsion technologies for aerospace overall. Next slide, please, Han. So if you're interested to read more about what we've done so far, we've got a raft of brochures, webinars out there and presentations. Lots of information is available on our website. When you get the slide deck, these are links, so feel free to link through them. You can also see the LinkedIn and Twitter at the bottom of that, so you can actually visit us there. There's a lot of information available to you. And with that, I'd like to hand over to Dr. Andy Sellers. Over to you, Andy.
There we go. Thank you, Amar. Not sure if you can see me or not, but thank you, Amar, for that excellent presentation. I hope everybody was paying attention with the numbers. There'll be an exam at the end of all this. I think just before leading off on the slides, thank you for the questions that are coming in. Keep them coming in, some really interesting questions. I stop my video. There we go. Can you see me now? Good, thank you. Let's have a look at some of the questions. Keep the questions coming in, and then I'll go into my slides. I'd like to make this kind of fairly interactive. You've seen some of the challenges and some of the opportunities that Amar has presented. So some very great questions coming in, but keep them coming in. So what do you consider to be the biggest challenge ahead to achieve net zero? I think this is probably, it's a combination of technologies and policies and societal change. So I think a lot of where our Catapult is positioned, as Amar has described, is improving energy efficiency and different ways of generating electricity. If you're using renewable energy sources, they're quite intermittent, so we need mechanisms to bank that energy when it's being generated. It might be windy in the middle of the night when you don't need the energy. You need to bank the energy when it's being generated into a battery or whatever, and then when you do want to use the energy, take that energy out and deliver it to the consumer. And that will require kind of a smart energy grid. It will require distributed batteries. The way the grid has been set up at the moment, it was set up in 1926 by the Central Electricity Generating Board. It's a very centralized grid. So we tend to have a few large power stations around the periphery of the UK, and then a grid that takes power from those power stations out to the consumer. And I think as we move forward, we're probably going to have lots of smaller distributed power generation, maybe solar, wind, other varieties of renewable energy sources, battery storage, and smart grids that can move that power around more efficiently. Now, the grid at the moment is actually quite efficient, but in order to be a flexible grid, we need lots of kind of power electronics to be able to switch that power around and make it much more sort of smart and much more flexible. And that's really where the compound semiconductors come in. So we've got a big role to play, but it's not all about us. There are some sort of big societal challenges, I think. With the COVID, we've all got very good at Zoom, and productivity through Zoom has increased enormously. So perhaps there's going to be a little bit of a change in terms of how we actually use transport. It's going to be transport when it's absolutely necessary, and it's more efficient if we do things over Zoom. So there's a couple of things like that. I think it's a blend, as I say, of the technology, the policy, and the societal change. It's trying to get that blend right, and it's also trying to take society with us. It's kind of trying to make sure that people are on board with the new ideas that are coming through. So let's see, wider discussion about human beings. Yes. Okay, so on the whole, I think in most sort of highly advanced, more mature democracies, populations are tending to fall. So Japan has got a falling population. UK, I think, is fairly static. It's not rising in some of the most of the first world countries, I don't think. But it certainly is something to be aware of, that we each need to sort of be careful that we are using, the amount of energy and our own sort of personal CO2 footprint, as it were, we need to be careful of. I think there's a big opportunity here for the emerging technologies, and emerging technologies across Africa. Rather than them going through the same industrial revolution that the UK went through, perhaps they could leapfrog and become a much more higher efficiency society and economy by adopting newer technologies. And that presents an opportunity for them, but also presents an opportunity for us. If we have some of those technologies, we can form relationships with those companies, those countries, and it provides perhaps an export opportunity for us to take some of those technologies out. Storage of lithium and other critical raw materials is becoming extremely, that's a very good point there. I'm just reading through these and then I'll come on to my slides in a second. Critical raw materials, you're quite right who has pointed that out. There's a number of of critical raw materials. The lithium for the batteries, for motors and things, it tends to be sort of the rare earth metals like neodymium and dysprosium. For compound semiconductors, they're not generally quite so critical. They're not quite so endangered. The materials are not quite so hard to get hold of. Things like gallium, historically, I think it was a byproduct of aluminium extraction from the earth, but actually Rio Tinto has just announced in the last couple of weeks that it is stepping up efforts to extract gallium, and I think strontium was another material. So certainly there is something that we need to keep our eye on to make sure that we have access to those materials as we go forward. Let's have a look at some of the other questions. If anybody, Amar, if you've got any comments and you want to jump in, please.
Yeah, I think if you move on with the presentation, what we can do is at the end we can actually take the other questions as well that comes up.
Sure. Okay. Hannah, if you want to go to the first slide. Cool. Okay. So Amar kind of described the opportunity. I just thought I'd present a little bit of the backdrop to how we got here. And actually, this isn't a part of political piece at all. It's just the kind of where we are and how we got. got to this situation. And actually, you know, the UK has shown kind of great leadership in all this, making a legal declaration. We were the first major economy to make a legal declaration to be net zero by 2050. That was signed in June 2019. And you know, that creates a disruption in the market, but also creates lots of opportunities. And you know, the UK is kind of at the forefront of this thinking. So this is really quite an exciting position for us to be in. And also we're kind of sort of stuck our neck out a little bit, because if we sort of cast our mind back to June 2019, at the time the US president was President Trump, and he wasn't entirely bought into this, and yet now we actually have had a change of position. President Biden seems to be much more in tune with our thinking, and we see there's a great, as I say, it's a kind of a great sort of leadership position to be in. It's quite a disruptive position, but it creates a lot of opportunities. Now, there's a parallel thing going on at the same time. I'm just going to draw some linkage between these two. At the same time as that kind of bit of legislation was going through for net zero, there's another piece of legislation which is going through, which is highly relevant. And this is on telecom security and telecom diversification. And that was announced last year. Predominantly it's got sort of three elements to it: sort of removal of high risk vendors from the UK. That comes back to this particular point about critical materials and access to technologies. It includes open standards, it includes vendor diversification. So again, it creates opportunities for UK companies to get a larger slice of the market. And I think the parallels I would draw here is that the telecom industry actually is responsible for something like 2 to 3% of global energy consumption, according to McKinsey, and growing at a phenomenal rate. And as we've seen with COVID, one possible sort of future scenario going forward is that we do a lot more of this kind of Zoom activity. So if anything, the telecom network is going to become more, more strained. It's going to require more build out, and therefore sort of more energy requirements. So kind of, the ultimate thing is, what are the implications for these sort of legalities for emerging tech? And I'll kind of delve into them in the next slide, please, Hannah. Thank you. So as Amar has pointed out, so a lot of the sort of technical trends which are emerging actually require access to new semiconductor materials. So we're kind of quite central to some of the debates that are taking place. And just as a sort of a snapshot of why that's relevant, you can see here just sort of three examples. In March 2018, we hosted, Aston Martin and Tate Athan actually hosted a visit by the previous Prime Minister to talk about vehicle electrification. So clearly this is very sort of high on the radar of sort of thinking about how we get to net zero. So our Catapult, being sort of in a neutral space, neutral non-profit research and technology organization, we are able to sort of quite often find ourselves sort of being pulled into these sort of discussions. And I mentioned the Telecom Security Bill, and there's a related piece of legislation which I'll just touch on here as well. There is the National Security Investment Bill, which is going through Parliament at the same time. And I've put some links in here to the transcripts for those who want to sort of read up on this. Now, the National Security Investment Bill it aims to bring the UK in line with other major economies, and it's particularly related to emerging technologies, new technologies, and companies that might want to divest part of their assets overseas. So it's all about kind of scrutiny of transfer of assets for emerging technologies. And the bill actually refers to 17 sectors, including advanced materials, communications, and artificial intelligence, amongst others, sort of 17 sectors. Companies that are wanting to, if there's overseas companies wanting to invest or take, acquire up to over a critical level, which is 25% of those companies, then it is mandatory to inform the Department for Business, Energy and Industrial Strategy. And at that point, there is a decision as to whether so far, this is how the bill looks like it's going to come through. At that point, there is an option for the Secretary of State to intervene in one shape or another. That intervention could be to sort of reshape the deal, or it could be to block the deal entirely. And part of the reason for this piece of legislation is that, as I say, it's kind of brings the UK in line with other major economies on sort of critical technologies that have been developed in the UK. And some of those critical technologies relate very much to net zero. So these are the sort of advanced semiconductors, and they also relate to telecoms, so advanced communication technologies and artificial intelligence. So these kind of core technologies, this piece of legislation is intended to protect. And as a sort of indicator on the previous slide, the other piece of legislation, which is kind of very relevant, is the Telecom Security Bill. So that has had its second reading in Parliament. We, as a Catapult, we were consulted on both of these pieces of legislation, and on the Telecom Security Bill. This is really about sort of removal of high-risk vendors from the network, but also disaggregating the network. So in parallel with the bill, there has been the formation of a telecom diversification task force, which is looking at how we actually break up the telecom network and open it up to new entrants. Now, at the moment, if we kind of roll back the clock to sort of 1990, there were lots of companies providing telecoms infrastructure, and the UK had arguably three global providers in the form of Marconi, STC, and Plessey. And as we roll the clock forward, what has happened is there's been massive consolidation in the industry to the point where we've got three monolithic providers of telecom infrastructure, those being Ericsson, Huawei, and Nokia. And this bill and the Telecom Diversification Task Force are looking at how we can disaggregate the network and how we can open that up to new entrants, and that provides a lot of opportunity to UK companies. So these kind of the sort of fairly common sort of strands here, the sort of the net zero, providing opportunities for new companies and opportunity for UK companies to get into that market. It's a disruptive technology that we can develop, and the telecoms again providing sort of access to UK companies to get into the market. So those are the sort of the backdrop. And on the next couple of slides, if we go on to the next slide, thank you, Hannah, I'll sort of talk about a little bit about how we, where we are positioned to help companies get access to these markets. Now, please keep the questions and the chats coming in, and we will address them. At the end of this. But so we've kind of described, Amara has described this kind of movement towards net zero and the technologies and some of the challenges and where we are, and that's coupled to this telecom diversification bill in many respects. So how does the Catapult help your company? Well, Catapult, we are a non-profit research and technology organisation. We are located in Newport. We have a very good track record of bringing companies together and developing innovative products in specific market areas. So we already have a track record of we're working on something like £100 million worth of projects for vehicle electrification. So the Catapult has brought together lots of consortia to get those projects off the ground. And specifically, what we have is we have knowledge of ecosystems. So if you're trying to address a large market, what you need access to complementary partners you can bring together. And we've presented this map here. So this kind of outlines in those two complementary areas of net zero and telecoms, where there are clusters of world-leading capability. So we can see, specifically where we are in South Wales, we have access to semiconductors and magnetics capability in net zero. We also have access in telecoms. We have access to cyber, digital design, small cell base stations, and of course the advanced semiconductors that we can put together. And there's quite a lot of complementarity here. And you can see as you go around the UK, different areas have different levels of capability. The Midlands has got excellent manufacturing processes. It's where the majority of the UK automotive industry is. In the Northeast, we have motor manufacturing and drives capability, and also a cluster of optical, radio and satellite communications company. And in Scotland, some photonics and cube satellite manufacturing capability. Northern Ireland sort of data center, something like 50% of the world's data center read-write capability is hosted in Northern Ireland. So you can see we're very, very well linked into all of these ecosystems. And effectively, that means we have access to customers, and we can pull together supply chains, and we can match different parts of the supply chain and different customers to suppliers. It really means we're kind of very central to these themes, to this theme of sort of net zero and future telecoms. So if you would like to go to the next slide, please, Hannah. Cool, thank you. So a little bit about the Catapult. We are funded indirectly from the Department for Business, Energy and Industrial Strategy via Innovate UK. We are a non-profit research and technology organisation. This is actually an artist's impression of the front of our building, but it's very, very similar to what it actually looks like now. We receive a grant over the 5-year period of about 53 million. We were established in 2017, and we've got about 80 staff at the moment. Now, we're part of a cluster of capability in South Wales, which includes over £600 million worth of investment. And that investment spans right the way from early stage material, semiconductor material development, right the way out to end product. So we have, within a very small geographic space of about 30 miles, the capability to do new semiconductor wafers, new semiconductor chips, put those chips into a subsystem and test that subsystem. And we do that specifically in those kind of 3 market areas that we've been discussing in this presentation. So the energy efficiency for net zero is one of our sort of leading areas where we can bring consortia together and put together supply chains to develop innovative products for net zero. And as Amar described, the big markets there are really sort of vertical electrification and energy conversion and smart energy grids. And also related to that, the telecoms and the resilient communications. We're calling that resilience. It's about resilience of supply chains and resilience of critical materials to make sure that we can continue to build out our telecom infrastructure and support the high data rates that we all require and the access and what have you as we build out 5G and other sort of different aspects to telecom networks. And the third strand is intelligent sensing. So a lot of our semiconductors are very highly sensitive sensors. They use some of the properties of quantum, so quantum light detection or very low magnetic detection, for example. And those sort of intelligent sensors will find applications in wearable health devices, being able to do early diagnosis of diseases. They will find applications in LiDAR and avoidance for autonomous vehicles, and maybe also kind of Earth scanning, so satellite scanning of the Earth to look out to map where energy usage is taking place and those sort of things. So we've got these sort of 3 focus areas that we have as a Catapult. And as I say, we're actually co-located with IQE, the world's leading developer of semiconductor wafers. And we're part of a cluster of about 4 or 5 universities and about sort of 10 private sector organisations representing over £600 million worth of recent investment into the region. So if you could move on to the next slide, please, Hannah. Cool, thank you. So you're very welcome to come and visit us. We have an innovation centre. This is what it looks like in Newport. You will see that it is very laboratory intensive, and that's the reason for that. Is we have highly trained engineers, highly skilled engineers, and cutting edge equipment. So if you're developing a prototype or a product, there are different steps in doing that. So we have access to laboratories where we can help you develop your prototype. And help you evaluate your prototype. we actually have sort of 5 zones of sort of proving capability within the catapults. And they are the design studio, the advanced packaging lab, the power electronics lab, the RF microwave lab, and the photonics and sensors lab. And they work very closely together. So the design studio enables you to simulate your product, do some simulation and modeling. So before you do any design, any build work, you can run it through high performance computing and check its performance characteristics. Packaging is actually the process of taking the semiconductor die and packaging that up and adding sort of thermal management onto it. We then have sort of 3 proving laboratories. So if you're doing a power module for an electric vehicle, you might want to test that at 0.5 megawatts of power. So you can bring that into our proving laboratory, and we can run some tests on it and do some evaluation. If you're developing 5G beam steering antennas, we have an RF and microwave laboratory. If you're developing quantum sensors for health applications, we have a photonics and sensing laboratory. So these laboratories are very closely linked together, all within the same building. We're also building out an incubation hub for micro and SME startups. When we're out of COVID, we'd be more than happy to welcome you into the Catapult, show you our facilities, and maybe even discuss how you might want to use our incubation hub. So next slide, please, Hannah. So I'm kind of going to round off here and then allow a little bit more time for questions. So this is the ultimate slide, and it kind of represents how we bring companies together to develop products. So this is sort of a supply chain map from early stage of the semiconductor processing, developing a wafer, and then developing a chip, and putting that chip into a product and taking that product out to market, be it an electric vehicle or a health sensor or what have you. And the Catapult kind of operates in the middle of this position. So we have access to companies within the cluster in South Wales that do the early stages of semiconductor development, and we have access to end markets who are looking for innovative products to take, end customers looking for innovative products to take to market to solve their challenges. And generally, when you're developing a new product, you go through an iteration loop. You kind of you model it, you do some modeling and simulation, and then you characterize it and you see if it works, and then maybe you integrate it into a product, and then you do some validation. And then if you're lucky, it works first time. Quite often that isn't the case. So you might go around that iteration loop a second time. So this is modeling, characterization, integration, and validation. And that kind of iteration loop, the fact that all of those facilities, all that capability is within the Catapult, means that we can go around that loop very, very quickly. So, and also we have oversight. So we kind of know when we're doing a modeling and simulation, we can kind of rely on our expertise and our experience. It gives us some indication as to what the best route forward is. So we can look at a number of different modeling. We can go into the laboratories, do some characterization. We have, as I say, we've got a packaging laboratory. We can integrate the chip into the module, and we can validate it, and we can quite quickly go around this loop. And that's critical because the time to take your product to market effectively is how many iterations of this loop you need to go around in order to solve the product, in order to solve the design challenge, in order to de-risk your product. So having those capabilities all under one roof is extremely helpful. I'll give a couple of examples, actually. I'll give an example. I've mentioned that we've been operational, we were started in 2017, and we're not really operational since sort of 2018. And since then, we've initiated something like £100 million worth of projects in vehicle electrification. And how those projects work is Amara's discussed sort of the challenges and how the government has stimulated the market in this area, and one of those market stimulations has been funding through the Advanced Propulsion Centre, and the Catapult here has helped bring together a consortia to develop a complete supply chain for silicon carbide. So the silicon carbide fabbed in the UK, silicon carbide being a compound semiconductor which has got very good power electronic properties. It's fabbed in the UK. We then make a silicon carbide chip, We then make a silicon carbide power module, and that power module goes into a sports car, in fact, a McLaren electric sports car. And we pulled together the entire supply chain to do that. And as I say, within that project, there are certain elements where the Catapult's capabilities come to the fore. So we are able to offer our modeling, characterization, integration, and validation capabilities to enable that project to take place. So we're very familiar with being able to build these supply chains, to get companies at all parts of the supply chain to develop products. Typically, our projects, we work very, very closely with very small SMEs and micro companies, and also we work with very large tier ones. And by bringing those together, it provides enormous value. It accelerates the ideas coming out of the SMEs into end user products. And typically our projects also have something like 80% of our projects have got academics involved in them. So we are always looking at the very cutting edge technologies and how we get them to market. So I'll kind of finish on that. That's my kind of final slide. And we look forward to hearing any further questions that you have on this in this area.
Should we take the questions, Andy, from
Sure.
here? I'll take a couple of questions and pass over to you as well for a couple of questions, Andy, if you don't mind. There's a question from Robert Alexander about what is your exit strategy when your funding runs out? So just brief explanation here. Generally, Catapults overall have what originally was called the thirds model. A third of their income is supposed to be from core grants, a third is from commercial income, and a third is from collaborative R&D projects. Now, not all Catapults start off with that. Obviously, you start off with core grants only, and then you create value by having commercial engagements as well as collaborative engagements. But generally, these are reviewed every 5 years. So Catapults tends to have a review in year 4, essentially. And the idea is that it continues, the funding, the core grant will continue to be there if the Catapult is relevant to what it's doing, right? Ultimately, we are here to make the SMEs and large companies rich in UK PLC. So we're not for profit, but the idea is to reinvest in order to get the UK PLC to move forward economically and advance technologies out there. So the principle here is pretty simple in that the exit strategy is only when compound semiconductors become a commodity as such, and the applications that we deal with are commoditized. In that case, we're no longer relevant as a Catapult, and that's the time when we should say, right, thank you very much, we move on to something else. It's supposed to solve an issue in the marketplace generally. And at the moment, the issue is we are at the inflection point, if you like, of moving towards a huge potential market for the UK, which requires an enormous amount of infrastructure as well as expertise, which is where the Catapults comes in. Hopefully that answers your question. There was another question that I could probably tackle here, which is, let's have a quick look, just run through here. Lack of charging infrastructure appears to be putting people off buying EVs, along with their high cost and range anxiety. To what extent is fear that hydrogen fuel cell will beat batteries, putting developers off from developing infrastructure? So I think hydrogen overall is always going to have a place in the green energy, right? At the moment, when you look at the big trucks, for example, and the large vehicles, including potentially trains in the future, they are probably more suited to hydrogen power than the standard kind of smaller vehicles. And so there will always be place for hydrogen generally, but it's probably not going to be in cars any time soon. That with caution. I think as technology develops, there probably will be a place for it, but at the moment it's too big and too cumbersome to have it in small, consumer vehicles, if you like. So there will be a place for hydrogen. And by the way, with hydrogen as well, there is conversion that needs to happen, and there will be a place for compound semiconductors there as well. So it's not a straightforward from hydrogen straight into the powertrain. There is a conversion element that's required there, and compound semiconductors can play a significant role. And do you want to take a couple of questions of your choosing?
Yeah, sure. how could we use green energy to immediately utilize the power to do work instead of using batteries? Yeah, if you're referring, thank you, Julie, for that question. If you're referring to kind of disposable batteries, totally agree. It's part of this kind of net zero journey is about sustainability more broadly. So this is about CO2 emissions, but clearly filling landfill with disposable batteries is no great idea. If they're rechargeable, then that's certainly a step forward. I think that there will be a need with green energy to have more rechargeable battery storage systems because of the nature of renewable energy sources. They tend to be intermittent, so you can't tell when it's going to be sunny and you can't tell when it's going to be windy. But there are other methods of storing energy. So there is a power station in North Wales called the Norwig, and what they do is during the night they pump the water from the bottom up to the top, and they store the energy as kinetic energy, and then during the day they allow the water to flow down, and it's hydroelectric, so it's like a gigantic battery. It's very efficient and it's very green. It doesn't need any lithium or anything like that. It's just water and weight. Somebody did also ask about sort of smart modular reactors and their sort of role. I think probably that plays into a bigger thing about how we built out the energy network in the UK. Is, as I say, it was kind of established 1926, the Central Electricity Generating Board, and it was large power stations feeding into a one directional grid, big power stations feeding into a grid into the homes and into the factories. And I think as we develop that further, it's likely to be sort of more small scale power generation and distribution and smart energy grids able to switch the energy around. And I'm sure that small modular reactors will have a place in that. UK is very good at this technology, in fact. And I think there was an announcement recently that there was going to be some support for small modular reactors. So I think they're probably part of the mix. It's about getting the bigger question is, what is the biggest challenge? It's about getting a blend of all of these different technologies to contribute towards the overall goal of net zero.
Just to add on the battery side of things, getting energy directly, right? One of the major challenges of smart grids overall and smart energy distribution is the principle that if you generate the energy that you do not use, you can actually sell it back to the network and distribution, right? There is a lot of work on that, including, for example, EV charging at home, right? If your electric vehicle is fully charged, you don't use it, there is a potential way to be smart about this and redistributing that energy to where it's actually used most. So there is three solutions to this. Whether or not you store the energy in batteries is obviously one of them. Generally redistributing the energy depending on usage, which is where smart energy distribution comes in. One is, as Andy said, there's some innovative methods at the moment where you use the energy, for example, solar energy to heat up water that allows for specific energy to actually move forward into heat energy and then transfer it back from there to something different as well. So there are many methods out there, but there is a lot of research in this area for sure.
I'll pick up on this question here about Catapult relationships with car makers. Yes, we have very good relationships with a number of tier one, brands you'd recognise on the forecourt. So please get in touch with us and we can take those conversations further. How do our facilities compare to others in the UK internationally? Extremely well is what I would say. And actually the cluster of capability we have in South Wales is globally recognised. It's unique because of the combination of everything. It's not just the Catapult, it's Cardiff University, it's Swansea University, good links into Bristol University, Compound Semiconductor Centre, IQE, the EPSLC hub at Cardiff University. All of these things work in synergy and in concert together. That is globally unique. It's globally recognised that what we have.
Okay, I think we're coming to a close, Andy, here. Just want to thank everyone for the questions there. As Hannah mentioned at the beginning, you can contact us. The email address is at the beginning of the presentation. Hannah, maybe you can go to that slide. There you go. Hannah, do you want to say a couple of words?
Thank you very much. Oh, sorry.
Look, Andrew, if you'd like to. Just to round up quickly, the first thing to say is thank you so much for the wealth of questions. We've had loads, so thank you. If you have any feedback on our session, then we'd love to hear it. You can email us at events@csa.catapult.org.uk. If we haven't quite got to your questions or you have further comments, then as Andy and Emma have said, we would love to continue to discuss this with you. And also if you're interested in finding out more about working with us, then please email our collaboration address, collaboration@csa.catapult.org.uk. You can also visit our website and follow us on social media. If you do download the PDF, as Amar said, the resources link will take you there, and also you've got the links here. So that's really the best place to find out our latest news and our upcoming events. The last thing to say is thank you to Amar and Andy for a great session. Thank you to everyone for joining us, and enjoy the rest of Emerging Tech Fest 2021. Thank you, everyone.
Join us again on our virtual live sessions or watch us on playback anytime, anywhere.